Welcome to the Scoliosis Dialogues. This is the official podcast of the Scoliosis Research Society. We're recording this week just before the annual meeting, so I hope to see all of you next week in Charlotte. Today we are focusing on two papers, and they're from the same authorship group, and we're focusing on robotics in spine surgery, or robotic-assisted spine surgery, RASS, R-A-S-S. We have two authors from this group with us, Dr. Ritt Givens and Dr. Joe Lombardi. Thank you both so much for being here. And would each of you mind telling us a little bit about yourselves, where you are in practice and in life, and how you became interested in robotics? And we can start with Dr. Givens.
Yeah, absolutely. Thank you so much for having us on. My name is Ritt Givens. I'm originally from New Braunfels, Texas, which is a small but growing town in between San Antonio and Austin. Studied biomedical engineering at the University of Southern California, and then moved to the East Coast for my medical training at Columbia University. I'm now back home in Texas at Dell Medical School in Austin, and I'm just finishing up my third month as a new orthopedic surgery intern. In terms of my interest in robotics, the initial push towards this work was secondary to, one, my background in engineering, but then also really just having incredible mentors who are deeply engaged in safety and outcomes research. And I think for me, it's become clear that being able to effectively incorporate novel technologies into practice represents the future of medicine, seeing the trajectory of innovation in this space from advances in navigation, imaging, and robotics really parallels the evolution of innovation we've seen more broadly, and watching how not just robotics, but enabling technology in general is reshaping much of what we do. I really wanted to be a part of better understanding and characterizing early adoption of new technology.
That's really great, Ritt. And I want to point out something that Ritt just said, and I want to point this out for any fellowship directors or employers in the future. Ritt just told us that he's an intern, and it's 5 a.m. where he is, and he's carved out a half hour for us on the Scoliosis Dialogues, which means that's a half hour that he's either not sleeping or not working. So we really thank you for your time. We know that yours is more valuable potentially than any of ours right now. And how about you, Dr. Lombardi?
Yeah, thanks, Rick. That's definitely dedication. So I'm Joe Lombardi. I'm an orthopedic spine surgeon at Columbia Presbyterian in New York City. And I'm a big believer in robotic spine surgery. I've been using robotic systems dating back to 2015. So I've seen the good, the bad, and the ugly of robotics. Despite that, I'm really encouraged about the future of robotics in spine surgery. But a couple of us really recognized that there were some unique risk factors to robotic spine surgery that we needed to identify and help the spine community understand how to best avoid them.
Excellent. And so, Dr. Lombardi, you harkens to the risk factors associated with robotic-assisted spine surgery. Would you mind giving us a quick few minutes of just a journal club style summary of these two new additions to the literature?
Yeah. And so, the injuries that you can sustain from robotic spine surgery are no different from those that you can get from either freehand screw placement or navigation. But we were seeing certain patterns of injury. And so a couple of surgeons, actually a large group of surgeons around the country at meetings, we would get together and start talking about these patterns of screw breach or even neurologic injury we were seeing with robotic assisted spine surgery. And so we decided to get together to help identify what those were and help give best practice guidelines for how we could avoid them. And so we sought to do two things. First was to identify and name what those patterns of injury were, and that was the classification system that we developed. And then the second part was to have a best practice guideline for, okay, we know what these risk factors are, but what can we do? How can we advise surgeons around the country and around the world in order to help avoid them from happening? And so that's where the best practice guidelines came in, and that's more of a step-by-step process on how to think about robotic spine surgery, how to implement changes and avoid injury.
And so within the classification that you developed, it's really giving us a standardized language for talking about these errors. And so if I were to, say, oh, this is a type 3 technique error, How would that change the way a surgeon debriefs at the end of the case as opposed to how they would have done it before this classification system?
Yeah, I think it does two important things. The first thing is that we are naming and identifying what these errors are. And for most of us, it was just we would get together at meetings and say, well, this happened or that happened. This is the first attempt to really put it all down on paper and classify what these things are. So I think by helping the spine community understand what the risk factors are, we kind of shine light on it. And so that can help us then better act on it. And then the second thing it does for us is it creates this lexicon that surgeons can speak to each other about this is what happened. It was a patient-related factor versus a surgical technique factor. And it helps us actually speak to each other about that and identify those things.
So one of the things that the best practice guideline recommends is formal training, and not just for us as surgeons, but literally for the entire surgical team. And it even identifies a lack of surgical team expertise as a potential root cause for errors like screw malposition. So what do you believe are the most critical aspects of training for a new robotic spine program? I guess secondarily, how can institutions best implement these? And then third, and this could be for Ritt or Joe, in your own practice or in your own observations, where do you see as our weakest links?
Yeah, I could take that. So, if you compare robotics to, say, a freehand technique, the freehand technique is almost entirely based on the surgeon's skill and intuition. Sure, we have a scrub tech who's going to be handing us instruments, but outside of that, it's really relies on the surgeon. When you have a robotic system, it really is a team of people working together. And so this involves the robotic technician mounting the robot to the bed. You have a scrub tech who needs to actually drape the robot, which can be a little bit of some technical steps. There are a lot of parts that have to be screwed in. In addition to that, you have a technician, typically from the company, who's helping to send the robot throughout the case. There may even be helping you plan your screws. So it really is more of a team effort. And in that respect, as you have more team members, it introduces more potential for error. And so what I would recommend is that every institution undergo some sort of formal training, as we did in the best practice guidelines. So what does that mean? Well, you can have an in-house training, and I do recommend that you do a dry run at your hospital with your surgical scrub tech team. But even before that, I would reach out to the companies, and they have labs that you should go and you should see firsthand, practice on a cadaver, how to set it up, how to drape it, and how to actually use the robot. Because while these machines are incredible, the first time you use it, you certainly do not want to be on a real patient.
Yeah, absolutely. And then I can just jump in as well. Something that Dr. Lombardi mentioned is the more people that are involved, the more opportunity there are for errors. But I think also on the flip side, the more people that are aware of the protocols and the more team familiarity there is, the more opportunities there are also to catch potential errors. And so having the training in place and whatnot really allows for more people to be aware of what's going on and potentially identify these sources of errors before they kind of propagate and occur.
And that also speaks to one of the barriers of robotics adoption too, is that as surgeons, we're relying on more people. And that can mean that it's a little bit of a longer setup, a little bit of a learning curve at first. And so once the more work you do on the front end in terms of training, the smoother the cases will go and the higher the adoption will be.
And so, Dr. Givens, in line with that, in your experience as a researcher and an engineer, how does this classification system make it easier for engineers to troubleshoot along the way, particularly when looking at large data models? And as a researcher, how does it make it easier for you to write up findings and communicate them to peers?
Yeah, absolutely. So the first part of that is part of this entire process of categorization and classification was similar to what engineers do in terms of a root cause analysis and identifying those places where these errors might happen. And one of the interesting things that I think we noted throughout the papers was the fact that these errors can kind of propagate. So one of the things that we talked about is motion, that motion can happen at a lot of different aspects of the case. And it's not necessarily just one factor that is contributing, but a propagation of multiple factors. And so looking at that from an engineering perspective, looking at ways where we can kind of tighten things up and mitigate the risk of motion at the various stages that we kind of identified it as being a potential problem. And then from a research perspective, having language to describe these things is incredibly important. Being able to categorize things is incredibly important. And then it really sets the stage for future research where we're moving from expert-derived consensus to more data-backed, data-driven research.
Yeah, and so you mentioned motion, right? And so motion is ultimately going to be the enemy of fidelity with robotics. And Dr. Lombardi, in the classification system, I think the type 2 errors are patient factors like obesity or large deformity as potential sources of error. And we've also talked about mounting the robot to the table. But just as important, if not more important, is mounting the patient to the operative table. And so how can a surgeon account for these patient-specific factors in their preoperative planning and in their operating room setup?
Yeah, so it's a great point. I think the most important thing about patient-related factors is that you identify them. So what does that mean? Let's say it's a patient with a large BMI. You don't want to use the robot or try to do the robotics through a small incision where the soft tissue might be pulling on the cannula. That's an instance where you identify it and maybe you say, I'm going to place my screws percutaneously. If it's a patient with a large deformity, for example, you may recognize that, hey, this isn't the best case for robotics here because of the angle of the spine or rotation of the spine, or the size of the pedicle is just so small that maybe I'll go to my more reliable freehand or a navigation technique. So I'd say as it relates to patient factors, it's hard to modify those. More of the onus is going to fall on the surgeons to identify them and then modify your plan, which may even include abandoning robotics in that case.
Excellent. In the best practice guidelines, it's mentioned that industry partners were consulted during the finalization of the guidelines. And I think that's something that has to be done, right? We can only move forward as partnerships with the people who are creating these robots and putting them in our hospitals. But how do you ensure that their input doesn't introduce bias or inadvertently favor certain technologies? Because without a doubt, there are companies right now that have somewhat cornered the market on spine robotics.
Yeah, so one of the things I was most impressed about throughout the BPG was our industry partners' openness to help facilitate these discussions. At no point do we get pushback from industry at all. And so the first a number of iterations through the best practice guidelines were done without industry being present. So when we came to the final meeting, most of our best practice guidelines were already in their rough form. And so at that final meeting is when industry was in the room, and they really didn't give any recommendations on what we should say. They were there more for the technical support, saying, for example, if we had a question about the actual technical aspects of the system, could they help weigh in? But they really didn't give any advice as to what the best practice guidelines should be in terms of changes that we should make. And they were great partners in that respect.
Excellent. So Dr. Givens, I know that you worked really hard in terms of setting up and writing these papers. And the BPG is based on expert consensus, and there's an acknowledgement that higher level data doesn't exist at this time. So what do you see as the next or the most crucial research step going forward to validate these recommendations?
Yeah, I'd say the next crucial step, again, is kind of moving towards outcome-based validation. And so things like multi-center prospective registries would be something that could really advance the research in this field, and comparative effectiveness studies, and even potentially things like simulation and training studies to, again, move from expert-derived principles, but really just getting data available, categorizing data, and classifying data.
Excellent. Yeah, I think it'll be interesting too to see, most of the research out there has breach rates for robotics at about 1%, which is comparable to navigation, certainly better than traditional freehand technique. After the introduction of these best practice guidelines, can we get that number down to 0.1%, or even strive for a never event for a robotic breach? And so that I think that's also, in addition to multi-center studies, the implementation and seeing how that changes breach rates.
That's excellent. I want to thank both of you for joining us on the podcast. Thank you for these additions to the literature, and I certainly hope to see more of your work in the future. Do either of you have any parting and final thoughts for our audience?
Yeah, I couldn't be more excited about robotics. I think there's so much coming in the pipeline down in the future, and it really actually goes beyond just placing pedicle screws. It's becoming more about a preoperative plan and an entire system from the moment you meet the patient all the way to execution, having tools in order to help execute.
Yeah,
Excellent.
absolutely. I would echo what Dr. Lombardi is saying, that it's incredibly exciting to see all of the innovation that's happening, even outside of robotic-assisted spine surgery, but in terms of healthcare and how healthcare is being delivered and transformed, and kind of making sure that we're able to adopt and incorporate these technologies in the most effective and safe way is kind of critical.
That's excellent. So I want to remind all of our listeners and viewers that the annual meeting is next week. So I will see you all hopefully in Charlotte. And even though we're getting ready for next week, we're already also planning for IMAST 2026 in beautiful Toronto, Ontario. So get ready for abstract submissions, which are already open, registration and hotels soon. And tomorrow, which will be the day this comes out, September 10th, registration for our first Asia Pacific meeting starts. So feel free to get on, register, and we hope to see you at the Asia Pacific meeting as well.